The Innovation Theater at CSCMP Edge is sponsored by KNAPP.
Hello, everybody. My name is Thomas. I'm happy to be here today to present in front of you. I actually work for a company called KNAPP. KNAPP is a leader when it comes to intralogistic technology. We are developing and implementing solutions for warehousing equipment, including automatic storage, sortation, robotics, software. So we have a very big product portfolio in that sector. And today the presentation will focus on the storage part of it. I will show you our product portfolio and I will explain a little bit which technology makes the most sense for certain use cases. And I'm also very happy to show you our newest family member of our storage solution portfolio, which is our first 3D shuttle. And that's actually what I want to start with. It's our Aerobot system. It's the first 3D shuttle from KNAPP. And it's a very simple setup. It's only one bot to store, one bot to retrieve, basically one bot to rule them all. No, joking aside, it's our first 3D shuttle, and there are many use cases why it makes sense to have a 3D shuttle. And there are advantages that a 3D shuttle have compared to other storage solutions. But I want to explain that in more detail a little bit later in the presentation. I first want to focus on traditional shuttle systems. In our case, our traditional shuttle system is called the Evo shuttle. We have a lot of experience with traditional shuttle systems. Basically, KNAPP invented those 25 years ago. We have more than 450 systems up and running across the globe with more than 50,000 shuttles. And we've developed that shuttle for certain industries, for certain use cases. But in general, a shuttle system is not very complicated to understand. It's, for those of you who have never seen one, I've prepared a short video. A shuttle system is basically a rack line. You have a shuttle robot on each level. The shuttle moves back and forth in the aisle. You can see here it's connected to a conveyor system. You have a lift. In our case, it's 2 lifts in front of the aisle. The lift transports the load carrier to a certain level. You store the load carrier at the intermediate buffer. That buffer position decouples the movement of the lift and the shuttles, which actually makes the shuttle the highest performance automatic storage system there is. And then the shuttle itself stores and retrieves the load carriers. In this case, you can see we have here mixed cases and totes. The shuttle uses the telescopes to store the load carrier, reshuffles in that case, because you have the opportunity with a shuttle system to store multiple deep, and retrieves here from the Z2 position, brings him back to the front, to the intermediate buffer position, and the lift grabs the load carrier. That's basically how a traditional shuttle system works. So you have one shuttle on each level and a lift that connects all those levels with a front-end conveyor. If you look at a system design with a traditional shuttle system, they're basically all very similar. You have a connection conveyor. That conveyor loop connects all the goods to person stations with all the aisles. And you fulfill the order then directly at that workstation. So you do not pass the target case from one station to the other. You have access to all the SKUs, you have access to all the load carriers in a shuttle block, and basically the conveyor loop is the connection between those goods-to-person stations and the shuttle. When you look at it from the top, the traditional shuttle system, you have service areas in the front and in the back, and you have between those service areas storage locations. In those storage locations, there's the shuttle running up and down, you have a lift, and then you have the conveyor loop that connects the goods-to-person stations. The shuttle is a very high available system, because in a shuttle, if a shuttle robot goes down, or if you have an error with one lift, you still have the other lift, which is still up and running, so you only lose performance, but it's still everything is available in an aisle. And with a shuttle robot, yes, you lose that level, but still everything else is up and running. And even if you go inside a shuttle and you have to correct an error, still everything above you and below you is up and running and the lifts are running. So it's a very high available system. And we are building those systems very small and very big. So there are multiple different solutions out there. Our technology now, we are able to build it up to 650 feet long, and we are able to build aisles up to 100 feet of height. There's this wideness as far as the eye can reach. That basically just means we can add as many aisles as we want. There are systems out there with millions of locations. And another very important aspect of the traditional shuttle system, which is an advantage compared to the 3D shuttles, is you're very flexible when it comes to load handling. Traditional shuttles can handle cases, totes, trays. You can handle all of them in the same system. And that's sometimes a huge advantage. If you think about pack and hold buffers, outbound buffers, you can handle the cases directly. You do not need a tray. You do not need a tote. We can handle different sizes of those load carriers in the same aisle, in the same shuttle block. And with the right software, you can even do that completely dynamic. What do I mean with that is, you can store double deep, triple deep, quadruple deep, all at the same time inside a shuttle system. Just you look, what is the next tote, what is the next load carrier, and you find the best possible solution inside the shuttle. We do have a different version as well, which is called the 2D shuttle. The 2D shuttle is very similar to the 1D shuttle, just with the big difference that we can roam between the aisles. What does that mean? So from a technology perspective, the shuttle looks exactly the same. You have the two telescopes, you have your main drive, you have everything that you have with the 1D, but the 2D has one additional feature, and this is the cross drive. And with this additional set of wheels in front of the shuttle, we can build systems where shuttles can leave an aisle and enter the next aisle, which means that basically every shuttle has access to all the load carriers on a certain level. That is a big, big advantage compared to the 1D for certain use cases. For example, one of the things, you do not need a conveyor loop anymore. You basically, instead of having a conveyor loop, which is connecting all the aisles with the workstations, you have a shuttle loop on every level. So the shuttles are looping instead of the totes on the conveyor. Another big advantage of a 2D installation is it's completely decoupling of performance and locations in the racking. So with the 2D shuttle, if you need more locations, if you have, I don't know, you have to store more SKUs in your warehouse, you just add racking without need to add shuttles, compared to the 1D where you always add an aisle where shuttles and racking is basically connected to each other. Or on the other hand, if you enter a new market and you don't have more SKUs, you just need more performance, you can add lift systems and shuttles to the 2D. Another big advantage that you can do with this 2D shuttle is you can build strict sequence inside the shuttle block. We are using that, for example, to connect the shuttle with automatic palletizing robots. So you build a sequence inside the shuttle block, meaning every shuttle has access to every lift. So you basically build a sequence, you build a pallet inside that shuttle block on a certain lift, and then you release the lift in sequence. That way, you can build that sequence for automatic palletizing robot inside the shuttle. Another advantage of the 2D compared to the 1D, and that's why we use the 2D mostly when we build huge systems, is the big advantage in availability. Because with the 2D shuttle, you have that huge advantage that every shuttle has access to all the load carriers in a certain level. Meaning, if a shuttle goes down, you just take out a shuttle. You lose a little bit of performance, but still all the other shuttles have access to all the load carriers. And even if a shuttle is down and is stuck in an aisle, you still, with the shuttle loop in the front and the cross aisle in the back, you still have access to all the load carriers always, all the time. Same goes for the lift system with the 2D. With a 2D shuttle, if a lift goes down, every shuttle has access to all the lifts. There is no problem at all. You just lose performance, but not availability. So if you look at those two next to each other, as I said, very similar, but different when it comes to when you use what. If you need high performance, you build the 1D shuttle, standard shuttle solution. If you need a strict sequence, or you need especially high availability, or you have a huge system where you have so much more locations that you don't really need the performance of all the shuttles, you go with the 2D. And we basically, as I said, we invented the shuttle system 25 years ago. The latest generation, the Evo shuttle, is on the market since, I think, 2018. But of course, we did not stop the development of our shuttle system. We are still developing features for the shuttle. For example, we are now able to use the shuttle in a freezer environment. We have already 2 systems up and running where we use our shuttle system to pick frozen goods. And I think we have another one coming up next year. We also see a demand, especially in Europe, for higher shuttle systems up to 100 feet. And we are prepared to do that. But of course, with a traditional shuttle system, what comes with such a high system is a lot of shuttle power, because you have all the shuttles on the levels, so you need also a lift system that can cope with that. You need a lift that can also achieve that throughput. So we developed a new lift system which is able to be as fast as all those shuttles, and so we can achieve up to 1,000 double cycles per aisle in the meantime. As I said before, we also work on our 2D algorithm. We use this 2D shuttle for our biggest projects, and we use it to build a strict sequence, as I said before. And therefore, we are constantly developing, of course, the algorithm to do that. You can see here the principle again, where we bring all the load carriers to a specific lift in order to build that sequence. And of course, with that long history of us, we have multiple shuttles out there with existing customers, shuttles that are 10 years old, 15 years old, and we know that there's a big responsibility for us as a provider, and we are prepared to also retrofit those and keep them alive in the future. So I talked a little bit about traditional shuttle systems, 1D, 2D. You need them for high performance. You have a very good storage density when it comes to high buildings, but of course, there is the demand for other solutions, especially when it comes to very flexible solution, when it comes to brownfields, when it comes to entry-level systems, when you want to build, when you don't want to invest that and you want to build not that complicated big systems, there is a demand for the 3D shuttles out there. And with KNAPP now, we have our own 3D shuttle, the Aerobot. And the Aerobot is a very simple setup. You have this one bot. The bot has a satellite bot on top of it, and the bot basically climbs up and down the rack. You can see it here. The bot climbs up the rack. The satellite bot goes inside the racking structure, and you store and retrieve the load carrier. You can see here it's quadruple deep. And that's basically everything there is. There's no other moving part. It's just this one bot. Everything is completely standardized. And you will see that also from our competitors, all the 3D shuttles are very standardized to, first of all, keep them as in a way simple as possible, to make them cost efficient and to reduce the lead time. Because that is one of the biggest advantages of a 3D shuttle compared to a traditional shuttle system. With a traditional shuttle system, you always talk 12 months plus. With a 3D shuttle where everything is standardized and you only have one load carrier and you always have the same shuttle that looks exactly the same way, you can achieve much better lead times, of course. So in a big picture, that's what it looks like. You basically have the bots underneath the racking, between the racking. You don't really have aisles anymore with a 3D shuttle. The aisles are just there to do some maintenance in case there is a problem with one of the bots. But the bots are completely roaming free on the floor. What I mean by that is you do not need anything specific on that floor. You do not need marks or something. That's all controlled by our own software, by our own fleet control software. Another highlight of that solution is the way the shuttle climbs. So it's friction drive. That means we do not need anything specific for the racking. The racking is a very simple rack because the shuttle really climbs only with friction. That makes it on the one hand very cost efficient and also on the other hand very simple. The quadruple deep storage in comparison with the ability to build it 40 feet high gives you an extremely good storage density. So that means with a traditional warehouse, you can really use the full space to the ceiling. And with the aerobot, as you saw before, the aerobot is roaming completely free on the floor. There is no specific shape a rack has to have. You can build the rack in an L shape, you can do a T shape, you can basically use all the square feet you have in the warehouse and put racking as much as possible in there. So when you look at our portfolio, we have on the one hand the aerobot, as I said before, very high storage density with the quadruple deep storage. We can build the racking in any shape or size, really up to your requirements in the warehouse, to the customer's requirements. And it's a very simple setup. You just have one rack, one bot. If you need more throughput, you add bots. If you need more rack, you add racking. So from that perspective, it's also a very good entry-level solution for automatic storage. On the other hand, you have our traditional shuttle systems with the Evo shuttle. Traditional shuttle systems, you can go sky high. You can achieve performances up to 1,000 double cycles an hour per aisle. And you have the big advantage that you can handle cases directly, for example, which makes sense in certain use cases. And I think the last thing that I want to really talk about in that presentation is in every warehouse you have storage, you have sortation, you have the process of manipulating goods in any way. We at KNAPP, we have the technology portfolio for all of that, from the item up to the pallet. So we have solutions for all of that different processes. But in the end, the most important thing is to have a software that really controls that in a certain way, that optimizes all of those technologies and that really connects those and integrates that in a solution. So in the end, the software is responsible to really provide a solution that gives a value over your whole supply chain. Thank you for being here. I hope you enjoy the rest of your day. If you have any questions, I think we have a couple of minutes. And if not, I will just stick around. Thank you.